Let me explain finite probability models. First, what is a finite probability model? A probability model with a finite sample space is called a finite probability model. Finite probability models are sometimes called discrete probability models. Statisticians often refer to finite probability models as discrete. In a previous chapter, we discussed two types of random variables, continuous random variable and discrete random variable. In this video, I am going to talk about discrete random variable. Then, what is the finite probability models or discrete probability models? We know I explained this in a previous video. Probability models consist with the values of the random variable and corresponding probabilities. Let me explain this example. Choose an adult in the United States at random and ask how many days per week do you lift weights? Call the response X for short. Right. First, let me discuss this a little bit. If somebody asks this question, what should be your answer? How many days per week do you lift weights? You may say 0 days, maybe 1 day, maybe 3 days, 6 days. But you never answer like 4.3 days. That means the random variable X has only whole numbers. Since there are 7 days per week, it must be 0 to 7. Then we have corresponding probabilities in the table. So this whole thing is called discrete probability model. Here random variable is discrete. Right. Now let me go to the part 1. Verify that this is a legitimate finite probability model. I discussed probability rules in the previous video. Here I am going to use some rules. What is the rule we use here? We know the probability of the sample space is 1. What is the sample space? X equals 0 to 7. So probability is 0 to 7. Then add probabilities. We need to check if this is 1. If it is 1, we can say yes, this is a legitimate finite probability model. Yes, it is true here. But if it is not 1, then this is not a legitimate finite probability model. Now go to the second one. Describe the event x less than 4 in words. We know x is what? The number of days lift weights. Therefore, we can define this event lifted weights less than 4 days. Then asking probability of x less than 4. First, we need to understand x values for x less than 4. What are the x values? X equals 0 to 3, not 4, because this is strictly less than 4. So, the number less than 4 is 3. Therefore, we consider x equals 0 to 3. Probability of x less than 4 equal the sum of those probabilities. That is 0.91. Then, how do we find the probability of x less than 4? You see here the x values 0 to 4. And the first 4 terms is probability x less than 4. Therefore, you can write this in this way. Then we already know probability of x less than 4. Therefore, 0.91 plus probability of x equal 4 is 0.04. Answer is 0.95. Now let me explain a little bit here. Probability of x less than or equal 4, that can be written as probability of x less than 4 plus probability of x equal 4. Another example, probability of x less than or equal 10 equal probability of x less than 10 plus probability of x equal 10. Here you see probability x less than 4 should be equal to the probability of x less than or equal 3. Again, x less than 4, that means 0 to 3. X less than or equal 3, that also 0 to 3. Therefore, both must be the same. Now go to the third one. Express the event lifted weights at least once in terms of x and find the probability. How do we write this in notation? X lifted weights at least once. That means the minimum is 1 or greater. X greater than or equal 1. Then how do we find the probabilities? The first understand the x values. X values should be 1 to 7. Therefore, we can write probability of x greater than or equal 1 as the sum of probabilities x equal 1 to 7. But you can use this one. It's easy to use here. But we can use the complement rule that I explained in the previous video for this case. What is the complement rule? Could you remember probability of A complement equal 1 minus probability of A. So here probability of x greater than equal 1 equal 1 minus probability of x less than 1. Understand x greater than or equal 1 mean 1 to 7. Then we need to consider the all elements in S but not x greater than equal 1. So what are the values of x greater than equal 1? It should be x less than 1. That means 1 minus probability x less than or equal 0 with equal sign. So what are the values for this? In this problem, we have only 0. Therefore, you can write 1 minus probability x equals 0. We know that is 0.73. So answer is 1 minus 0.73 is 0.27. Now think about this again. Probability of x greater than equal 4. That must be equal to 1 minus probability of x less than 4. We have greater than or equal. Therefore, when you apply the complement rule, it should be the same number x less than 4 but not equal sign. Okay, the same number 4 in the both side, or you can write this probability of x less than or equal 3. And here again probability of x greater than 4. You have strictly greater than 4. Therefore, when you apply the complement rule, it should be 1 minus probability of x less than or equal 4.